Have you ever looked at your Python project folder and just sighed? You know the feeling. It starts out so simple, so clean, and then before you know it, it's a complete mess. Well, in this explainer, we're going to tame that chaos. We'll turn it into a clean, professional structure using one of Python's most powerful, but sometimes misunderstood features, packages. Let's dive in.
Oh yeah, we've all been there. It always starts with one little file, right? Main.py. So innocent. Then you add helpers.py. Okay, fine. But soon you're drowning in files like databasestuff.py, utilsold.py, and my personal favorite, script_final_I_swear.py. It's a total mess, but don't worry, there's an incredibly elegant solution built right into Python to fix this exact problem. So here's our game plan. First, we'll talk about going from chaos to clarity. Then we'll answer the big question. What exactly is a package? We'll demystify that kind of strange __init.py file, see how to put it all to work, and then, the best part, we'll talk about the huge payoff, why this is so worth it.
All right, let's kick things off with section 1, from chaos to clarity. We need to understand the problem before we can really appreciate the solution, right? Every single one of us starts right here. A single Python file, which, is technically called a module, is absolutely perfect for a small script. But what happens when that script starts to grow? You add more functions, more classes, and suddenly you're scrolling through hundreds, maybe thousands of lines of code just to find one little thing. It's a headache. This approach just doesn't scale. And this is where the hero of our story enters the scene, the Python package. This is the simple yet powerful idea that lets your project grow up without falling apart.
Here's the best way to think about it. A module, that single .py file, is like one tool. It's a hammer. Super useful, but it's just one thing. A package, on the other hand, is the entire toolbox. It's a directory that neatly organizes all your related tools, all your different modules, into one logical, easy-to-find place.
So here's what that toolbox looks like in the real world. You've got a folder, My Package, and that's the package. Inside, we've organized our code into logical files, or modules. One for all our string-related functions, another for our math functions. It makes perfect sense. But what's up with that third file, the one with the double underscores? That, my friends, is the secret sauce.
Okay, let's talk about this file. I know, init-py looks a little weird with those dunder methods, the double underscores, but it is the absolute key to this entire system. It's what makes the magic happen.
And here is the single most important thing to remember. The mere existence of an init.py file, even if it is completely 100% empty, is what tells Python, hey, this isn't just some random folder, this is a package. You can import things from here. That's it. That's its primary job. So this little file really has two main jobs. Job number 1, as we said, is being the magic flag that tells Python this is a package. Without it, Python won't even try to look inside for your modules. And job number 2, which is optional, is that you can actually put code in here that will run just once, the very first time the package is imported. It's perfect for any kind of initial setup you need to do. Okay, section 4. We've built this beautiful, organized structure, we get the theory, but how do we actually, use the code that we've so nicely organized inside of it?
It's actually super simple, and the syntax is called dot notation. Honestly, it's incredibly intuitive. It works just like a file path. You just write the package name, then a dot, then the module name you want to access. Package.module. Easy.
So the first way to do it is to import the whole module. This is like going to your toolbox and pulling out the entire drawer labeled string utilities. The code from my package import string utilities gives you access to every single tool, every function inside that module. Or, and this is often even better, you can be way more specific. This second method is like opening that string utilities drawer, but only grabbing the one specific tool you need. In this case, just the reverse function. This is great because it keeps your main script's namespace clean and only brings in the exact functionality you need. All right, we have covered the what and the how, but now for the most important part, the why. I mean, really, why should you go through the trouble of organizing your code like this? What's the big payoff?
Let me tell you, the benefits are massive. First, you avoid name collisions. Your helper function in your mathutils module won't ever clash with a different helper function from some third-party library. Second, it forces you to group your code logically, which makes it a million times easier for you or your teammates to understand what's going on months later.
And then there's the holy grail, reusability. A well-designed package can just be dropped into your next project, saving you a ton of time.
And that's really the bottom line, isn't it? This isn't just about being neat for the sake of it. Using packages fundamentally elevates your code. It transforms it from a jumble of files into a robust, maintainable, and truly professional project. This is a core skill for any serious Python developer. So let's do a super quick recap. What did we cover? Packages are just directories with that special --init.py file. Their whole job is to organize your code into logical groups. You use simple dot notation to import stuff from them. And the key benefits? No more name collisions and way better code reusability. Simple as that. I'll leave you with this fantastic thought from the great B.B. King. You now have this knowledge. You know how to structure your code like a pro, and nobody can take that away from you. So the only question is, which one of your messy projects are you going to transform first? Go build something amazing.